Question 1, an aromatic metabolism question. Now, I'm not talking about the biochemical issue here, but this is one of the reasons why polyaromatic hydrocarbons are carcinogenic. It's because specifically the right alkene can be epoxidized and then opened biochemically. So this is just a chemical version. So mechanism for epoxidation followed by acid ring opening. So let's get started. So the epoxidation, I'm going to turn this on its side, makes it a little easier to draw. So I've got the isolated alkene, which reacts because, even if I get rid of it, I still have two aromatic systems. We'll talk more about that in organic 2. And then I have the odd peroxy acid that's capable of some interesting tricks with its structure. The short version is that we're going to end up with a carboxylic acid and an epoxide. So we have basically the carbonyl taking that hydrogen. We have those electrons ending up being nucleophilic. We have the oxygen also acting partly electrophilic because the other oxygen can act as a leaving group, which it does, forming a pi bond here. So if we trace that all the way around, what we end up with is now a 3-membered ring here. And we'll just draw one. So that we now still have 2 benzene rings, but this piece wasn't in conjugation anymore. And if I leave everything where it was for the peroxy acid, here's where the rest of those atoms ended up. Is I have now, where it was a double bond, it's a single one, and where it was a single one is a double one, and the missing oxygen is the epoxide one. So that's part 1 of the question, getting the epoxide mechanism. There's a lot going on here, but we've covered it more than once. So hopefully you got that part right. Basically, a lot of people did get that part right. Oddly enough, a lot of people had more of a problem with the second step, which was the acid catalyzed ring opening, which is actually fairly straightforward, but some of you did some very odd things with that. First, protonation. Whenever we're dealing with an acid, that's probably a good place to start. I would have thought that was a given. I was wrong. So, protonation of the epoxide. That's how acid-promoted reactions work. They generally have protonation of an oxygen or a nitrogen involved in how they work. The oxygen version is a lot more common. We deal with that a lot. So we're here now. We now have the, very poorly drawn, but we now have a protonated version of that. It's really close there. We now have protonated epoxide, which means we have a leaving group. We have the strain already, but adding protonation to it means that oxygen to carbon bond is much weakened, and so we now have the ability to use even a weak nucleophile to do a ring opening with. And that gets us to the version that now has 2 oxygens attached. Assuming I draw it right. So now I have an alcohol where the ring opened, the original oxygen that was there, and I now have a protonated alcohol on the opposite face. So if I take that, still in water, water will take care of that by reforming the hydronium ion, and I get the product diol. Now, a few things that people did, I don't understand, but a few things that I do understand that are very wrong. You do not, under any circumstances, ever, and I mean that with the voice of a deity, ever, 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 thou shalt not use hydroxide as a reagent in an acidic solution. Period. Ever. When you start drawing an OH minus in H3O plus solution, you have completely lost your way. So please don't do that. You cannot use base as a reagent in an acid. They are absolutely incompatible with each other.